The universe is a masterpiece of extremes. It holds beauty beyond imagination, shimmering galaxies, swirling nebulae, and the silent elegance of star-filled skies. This essay dives into 5 of the most extreme and frightening environments known to astrophysics. 1. Neutron stars. A neutron star is what remains after a massive star collapses under its own gravity during a supernova. What makes it terrifying is that the collapse does not go all the way to a black hole, but it gets just close enough to stretch the known laws of physics to their breaking point. This is the realm where atoms cease to exist, where electrons are crushed into protons, where matter becomes so dense that a teaspoon weighs more than a mountain range. To understand neutron stars, we must step through the most violent birth in the cosmos. Number 1. The birth of a neutron star, an apocalypse of physics. Every neutron star begins the same way. A massive star dies. A star at least 8 times the mass of our sun burns through its nuclear fuel until the core becomes mostly iron. Iron cannot produce energy through fusion, so the star loses its internal support. Gravity, the same gentle force that makes apples fall, becomes an unstoppable monster. The core collapses at 1/4 the speed of light. The collapse pressure skyrockets. Electrons are forced into protons. The reaction creates neutrons, neutrinos, billions of trillions per second, escaping into space. This process is called electron capture. The neutron wall. The collapse stops suddenly when neutrons become so tightly packed they refuse to compress further. This moment, lasting milliseconds, creates a shock wave. That shock wave blasts off the outer layers of the star as a supernova. A neutron star is a layered nightmare of physics. Let's peel it apart. The atmosphere, just a few centimeters thick, made of superheated plasma, gravity so strong that flames burn flat, gas cannot rise, heat cannot convect normally, even photons struggle to escape. Outer crust is a rigid lattice of atomic nuclei floating in a sea of electrons. The inner crust, atoms no longer survive. Neutrons drip out of nuclei like water from a sponge. Density here reaches 10 kilograms per cubic meter. Core, the densest matter in nature. Here all atoms are gone. Matter becomes a fluid of neutrons, possibly strange quarks, maybe even quark-gluon plasma, a primordial state from moments after the Big Bang. The speed of sound in this core, half the speed of light. That means a shout would circle the star in milliseconds. If you dropped a paperclip, it would hit the surface at half the speed of light. A human landing on a neutron star would be flattened into a thin film of atoms in less than a microsecond. Escape velocity is almost 0.770% speed of light. Nothing we know could lift off. Black holes, the universe's final predators. If the universe were a jungle, every object would instinctively avoid one creature, the black hole. Not because it is violent, but because it is absolute. A place where reality bends, physics breaks, and time itself surrenders. Black holes do not exist in the normal sense. They are regions of space-time so warped that nothing, not even light, can escape. In the cosmic wilderness, they are the silent hunters. Let's peel back the layers of this terrifying phenomenon and explore the physics that makes them the most feared places in the cosmos. Number 1, what is a black hole? In physics terms, a black hole is created when enough mass is compressed into a small region, causing gravity to become so strong that escape velocity exceeds the speed of light. The boundary around a black hole is called the event horizon, a one-way door. Cross it and you never return, not because you're trapped, but because all future paths point inward. Even light, which defines visibility, is bent too steeply to escape. Singularity. At the center lies the singularity, a point or ring for rotating holes where density becomes infinite and space-time curvature becomes undefined. This is the point where physics we understand collapses and quantum gravity takes over. Number 2, how black holes form. A. Stellar mass black holes born from the cores of massive stars, 8+ solar masses. When nuclear fusion stops, gravity overwhelms everything and the star collapses. B. Supermassive black holes, millions to billions of solar masses, found at the center of nearly every galaxy, including the Milky Way. Their formation mechanisms include collapse of gigantic gas clouds, mergers of many smaller black holes, runaway growth from accretion over billions of years. C. Primordial black holes, hypothetical tiny holes formed seconds after the Big Bang due to extreme densities. Number 3. Falling into a black hole, what you'd actually experience. Scientists call this nightmare journey, spaghettification. A black hole doesn't simply eat you, it pulls you apart atom by atom due to extreme tidal forces, the difference in gravity between your head and feet. For a small black hole, 10 to 20 solar masses, you would die outside the event horizon. The tidal forces rip you before you even touch the boundary. For a supermassive black hole like Sagittarius A, you might cross the event horizon alive, but time and space distort until your atoms fall into the singularity. Number 4, time dilation. The scariest part. Einstein's relativity tells us that time slows down near massive gravity wells. Near a black hole, it slows down dramatically. To an outside observer, your fall appears to slow, your image freezes, you fade to red and vanish. To you, time flows normally, but the universe outside speeds up. Stars race, galaxies move, billions of years pass in moments. Black holes are cosmic time machines, but they only move you forward, never back. Magnetars, the most dangerous objects ever discovered. If the universe had warning labels, magnetars would carry the biggest one. They look harmless, just small, quiet, cooling stars, but hidden inside them is a force so extreme it defies imagination. Magnetars are neutron stars with magnetic fields 1 trillion times stronger than Earth's, capable of tearing atoms apart, distorting matter, wiping digital data clean from thousands of kilometers away, and extinguishing life across star systems. They are, without exaggeration, the most dangerous stable structures in the cosmos. Let's dive deep into the physics that makes them terrifying. Number 1. What exactly is a magnetar? A magnetar is a neutron star, the collapsed core of a massive star, but with one extreme difference. A magnetar's magnetic field equals 10 square 10 Gauss. Earth's equals 0.5 Gauss. That means a magnetar is 1,000,000 times stronger than Earth's magnetic field, strong enough to warp atomic orbitals, strong enough to collapse electron shells and change chemical behavior. Matter near a magnetar doesn't behave like normal matter. It becomes stretched, elongated, and deformed. Number 2. How magnetars form. They are born in the most violent way known, had a hypernova or the collapse of a massive star. When a huge star dies, its core collapses into neutrons, packed so tightly a teaspoon would weigh billions of tons. But in rare cases, the collapsing star is spinning so fast and has such intense magnetic fields that rotation accelerates, magnetic field lines twist, dynamo effects amplify the field to unimaginable levels. Only about 1 in 10 neutron stars become magnetars. Number 3, the strongest magnetic fields in the universe. The magnetic field of a magnetar is so powerful that it can erase credit cards from 100,000 miles, 160,000 kilometers. It can deform the electron clouds of atoms. It can generate magnetoquakes, starquakes that release more energy in 0.1 seconds than the sun emits in 100,000 years. This is not hypothetical. We have observed these explosions. Number 4. The starquake, cosmic earthquakes that tear reality. Magnetars have crusts, solid iron-like shells a few kilometers thick, but their magnetic fields twist these crusts until they crack. A single starquake causes a magnetar giant flare, a burst of gamma rays, X-rays, high-energy particles. The 2004 flare from magnetar SGR 180620 released as much energy in 0.2 seconds as the sun emits in 250,000 years. Earth was 50,000 light years away, and it still disrupted satellites. If this magnetar were 10 light years away, the flare would have sterilized Earth instantly. Number 5. Quantum physics at play. The vacuum breaks. Magnetars are the only known objects capable of producing a real effect predicted by quantum electrodynamics. Vacuum birefringence. The magnetic field is so strong it turns empty space into a crystal-like medium that bends light. Empty space becomes solid-like. This is physics at its absolute limit. Number 6. Why magnetars are more terrifying than black holes. Black holes kill you only if you come close, but magnetars, they kill you from a distance. A magnetar 1,000 kilometers away shreds your atoms, disrupts your brain chemistry, melts your molecular structures. A magnetar 1 million kilometers away wipes electronics, erases magnetic storage, damages satellites. A magnetar 1 light year away, a giant flare could destroy ozone layers, expose planets to deadly radiation, trigger mass extinction. Magnetars are cosmic weapons that detonate without warning. Number 7, magnetic death zone, the magnetosphere. Around every magnetar is a region filled with accelerated particles, twisted field lines, plasma arcs. This area is so violent that it produces X-rays, gamma rays, cyclotron radiation, pair production, matter, antimatter creation. It's a region where electromagnetism rules physics, not gravity. Number 8. Why magnetars are so rare? Thank the universe. If magnetars were common, life in the galaxy would struggle to exist. Planetary systems would be sterilized regularly. Star-forming regions would be disrupted. Humanity survives partly because the galaxy keeps its magnetars far apart and mostly hidden. Number 9. Why magnetars are essential to the universe. Despite their terror, magnetars seed heavy elements, sculpt star-forming regions, influence galactic chemistry, power mysterious cosmic events like fast radio bursts. They are destructive, but also creators. The universe uses violence to build beauty. Up section, the boat's void.